Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding a 2D Game Engine in Java series. So in this episode what we're going to be doing is setting up key listeners and mouse listeners. And these events are actually pretty easy, so I'm not going to belabor the topic. We're just going to sort of move through it. It is different than when we did it in the auth library because we have to do things a little bit more explicitly, but it's still not too bad. And I'm going to show you a cool trick we can do at the end to fade the screen to black after we set them up on a key press, just so that we can explore what we've done. I'm also going to show you how you could set this up with Gamepad controllers and stuff if you really want to, because GLFW gives us that opportunity. Okay guys, so let's see how to do that real quick and let's get it done. So before we start coding, I did want to go over something simple because I think in the last series I did this a little bit weird, and that is the dx and dy values. So when you are in your game engine and you have the mouse move, you have these values called dx and dy, which basically represent, so say that was the position on frame 0, and then the mouse moved to this position on frame 1. So it's moved this distance vertically and it's moved this distance horizontally. And I think what I was doing was I was saying like the absolute position. So say this was 0, 0, I would say, okay, the mouse x, mouse y is now, this is 2, 1, and I would say, and dx dy is 0, 0, which makes no sense. What it really should be is dx dy is this value right here, which is 1. It's traveled to hold a distance of 1 in the dy direction, so delta y, and then delta x is equal to 2 because it's traveled 2 units to the right. And so this is really what I just want to make sure we fully understand is when we're coding these dx dy values, we do want to set these to the distance elapsed between the last frame. And in order to make sure that this is always correct, we also need to reset these at the end of every frame. So we need to call something called end mouse frame, which will end up resetting these values to 0, because if we're using these dx dy values and the mouse has not moved at all, then it has moved 0 units in the right and 0 units up and down, which is exactly as it should be. And we just want to make sure we're resetting that, because if we don't, then we can get some weird bugs. So dx dy position, we travel in the vertical and horizontal direction, and we reset those at the end of the frame. Now let's code this. Okay, so we will code those in just one moment, but before we do, I want to go over one last thing I forgot to do. So we create this whole window and everything, and when we're doing this in LWJGL, it actually does it a little bit differently. Since we're using C bindings, we allocate resources, memory. We're allocating that ourselves, and Java is not handling that memory. And so when we create a window and everything, we grab a chunk of memory, and if we want to be proper, then we should free the memory once our loop has exited. So right here inside this run function, what we should be doing is we should say GLFW free callbacks, and this will free any callbacks that are attached to the window, which we don't have right now, but we will in just a second. And then GLFW destroy window, and we pass it the GLFW window. And then we want to terminate GLFW, and we want to free the error callback. So these are the last sort of error freeing, resource freeing methods that we have to call. So free the error callback. So then we would say GLFW terminate, and then GLFW set error callback. And we would say null because we're setting the error callback to null, and then we free it, we free the memory. And so, I mean, this isn't strictly necessary. The operating system will clean all this up for us if we don't do it, but if you want to be proper, you should add it in. And this was also included in that tutorial that was linked to the LWJGL.org site. So add those in if you want to be proper, and it's all good. Next, what we're going to do is we're going to create our key listener and our mouse listener. So we'll create a class, and we will call this mouse listener. Since this one's a little bit more complicated, we'll do this one first. And we want to set up a few things. So this is going to be a static class. So what we want to do is we want to give it a static instance. So we'll say mouse listener instance. And this is going to be our singleton. So this is the singleton of the mouse. And we're going to create a few variables that we will keep track of. Scroll x, scroll y. And then we also want some doubles, x pose, y pose, last y, and last x, and those will be for our dx dy values and stuff. And then what we'll do is we will have a Boolean array, mouse button pressed, which will store which button was last pressed. we'll say is a new Boolean, and we'll initialize it to 3. I believe there could be more, but 3 is the only buttons on this mouse, so I don't have to worry about it, and you typically don't have to worry about people pressing more than that. We'll add a catch in there just in case there's more than 3 buttons. And then we'll add in another Boolean is dragging, which will let us know whether the mouse is dragging or not. And that should be good. We'll have to add in a few more variables once we start doing projections and stuff, but for now we are good. Projections, which means we're just matching the screen to fit how many pixels we would like it to look like are on the screen. So we'll get to that a little bit later. But let's create a private constructor now. And reason we're doing this private once again is because this is a singleton and we don't want this to be public to other classes. The only class creating this should be the MouseListener class. So we'll say scroll X is initialized to 0, scroll Y is also initialized to 0, X pose is 0, Y pose is 0, and last X is 0, and last Y is 0. It is important that you initialize these values because if you're using them and the very first frame, you can get some weird bugs if you don't have these initialized to 0, because it will be like, oh, the mouse is in some random memory position or something like that. So just make sure you do that. Then what we're going to do is we're going to create that get function, which is very simple. We did this in the last tutorial too. So we'll say public static mouse listener, and this is going to be called get. And we're going to say if instance equals null, which it will on the first time we call this, then we'll say instance equals a new mouse listener. And then we'll just return the instance. And if you want to be more specific, you could say if mouse listener.instance, just so that you know exactly what you're talking about. And then you could just say return the mouse listener.instance. Okay. Next, we're going to actually create the callbacks that we will be calling. So in order to figure out what callbacks you would have to do, you could go to GLFW callbacks, the input guide. Then it has all these different titles and everything. It shows the GLFW pull events, wait events, all the different things they give us. Then it says keyboard input, and we see this thing called key input. And it says we need to set a callback, a key callback, and then for the key callback, we need a function that looks something like this. This is in C, so it's going to look a little bit differently than when we use it with LWJGL, but typically you just replace this with a long instead of this GLFW pointer, which is what that star is, then you'll be fine, and then everything else will remain the same. The one we're looking for is mouse input, so we want this static void cursor position callback, which is the first one we'll implement. So let's go back to our code real quick, and we'll say public static void mouse pose callback, which will take in a long window. And then if we remember, it had an X position and a Y position, both doubles. So then we'll say double X pose and double Y pose. And it's important that these match that callback because we will need this exact definition in order for it to work properly. Then we'll just say get.last, .last X equals get.X pose. So we're setting the last X and the last Y before we change it to the new X and the new Y. So basically we're saying get to get our mouse listener, and then we're just grabbing the variable and resetting it according to what it needs to be. And then we're going to change what the variable actually is now. So then we'll say get.xpose equals xpose, and we'll say get.ypose equals ypose. And then we'll see how that goes once we get to it. Now we want a mouse button callback. So let's go back to here, and we will look for a mouse button callback. So it has cursor mode, raw mouse position, cursor objects. We keep going down. Cursor, enter, leave, mouse button input. Here we go. So then we see it says there's a mouse button callback, and then the definition looks something like this. We have the window, the button, the action, and the mods, which are just modifiers. So we'll go down to here, and we'll say public static void mouse button callback. So mouse button was pressed, takes in a window, and then let's go back to there, and it takes in a button, an action, and modifiers. So we'll say int button, int action, int mods. And modifiers are just like if you were pressing the control key while you clicked or something like that. So that's all that modifiers are, which you need sometimes if you're checking for like control C or something like that. You have a modifier key being pressed while you press another key. So then we'll say get dot mouse button pressed, and then we'll say button equals true. So the button was just pressed. Actually, was the button just pressed? We don't know. You do have to check one more thing. So we can check if it was pressed or released. If we say action, so if action equals GLFW press, then we know it was pressed. And we can import that hitting Alt-Enter. Else, if action equals GLFW release, then we know it was released. We can say get that mouse button pressed button equals false, and we will turn that off. And if it was released, we also know that if it was dragging, it is no longer dragging. So we'll just set that real quick because we know it's no longer dragging. Now, what if the mouse has more buttons than we have programmed into our Boolean? We only set 3. We should check for that because just in case you have one of those fancy gaming mouses, I don't know, and you press more than one button, you don't want that to throw an error here. So we'll say if button is less than mouse buttons, get.mouse button pressed .length, we'll set it. Otherwise, we'll just ignore it. And then we'll do the same thing here. Well, actually, we'll just copy that and check and see if we have enough room in that array to store that. That way we can just catch that just in case. Next, we want the mouse scroll callback. So we'll keep scrolling down. Scroll input, look at that. So we have a scroll callback, takes in a window, an X offset, and a Y offset. So we'll go back into here and we'll say public static void mouse scroll callback. And we'll take in a window, and we'll take in, I believe it was a double X offset and a double Y offset. And we can just say get.scrollX equals X offset and get.scrollY equals Y offset. And I spelled scroll wrong. And you may be wondering, why am I doing the get? Well, that's because we're making all these static, because when I'm coding inside my application, I don't want to have to do MouseListener.get. I want to be able to just say MouseListener is mouse pressed and pass in a button, GLFW button 1. And that's how I want it to be. So if we make all these static, then we can call all these functions statically, which just makes it a little bit easier. And also, the callbacks do need to be static because when we're passing them to our callback handler, it's easier if they're static than if they were member variables and stuff. So we'll see that in just a second too. Now, that is it for the callbacks that we need. Let's add the end frame function that I was talking about. So we want to make sure that we're ending these frames. We'll just say get.scrollX equals 0. We'll reset the scroll and the deltas. So then we'll say get.lastX equals get.xpose, which will inherently set the deltas to be 0, because now if the last X and the last Y are the X and Y that we're currently at, when we subtract those two, we'll get 0. So that's what we do. Next, we'll make all our static getter functions. So we'll say float get X, which will be like get where the mouse X is. We'll say return float get.pose X, or xpose. And then I'm just going to copy this whole thing. We'll do get Y. And so instead of X's, we'll just say Y, and we'll say Y. Next, we want get dx. So I'm just going to copy this again, and we'll say get dx. And this one's going to return the last X minus xpose. So we'll say get last X, and I'm going to wrap this in parentheses so that we cast this whole expression to a float. And then we'll say minus get.xpose. And that will just give us the amount of elapsed X position in the current frame. Then we'll say get dy, if I can type right, and change this to Y, change this to Y. And then next we want scroll X and scroll Y. So say public static float get scroll X. And there is scroll X, some mice, I'm not sure what the plural of that is. They do have a scrolling in the X and the Y direction. So that might be useful if you want to do that. So we'll just say get.scroll X. And then we also want scroll Y. So we'll do this one more time. And we will change this to a Y and change this to a Y. And we want if it's dragging. So we'll say public static Boolean is dragging, return get.is dragging. And then next we want, I think that's it. Mouse button down. So we want to check and see if a mouse button is down. So we'll say a static Boolean mouse button down, and we will take in an integer for the button, which is what GLFW gives us. So GLFW mouse button 1, we have all these different things, and those are just integers. So we'll say return get.mouse button pressed, and then we'll say button. And we'll do that check inside here too, just in case. We'll say if button is less than get.mouse button pressed.length. We'll return this guy. Otherwise, we will just return false, so that we have our bases covered and we will not get any errors. Now, is dragging, how do we know if it's dragging or not? Well, the way that GLFW calls our callbacks is it calls the button callback and then it calls the mouse position callback every time the mouse is moved. And the way we've set it up is if we get our mouse button callback called, so if we look up here, we have our mouse button callback, we say if it's pressed, we set the button to true. So while it's pressed, we won't set this to false until it's released. So while it's pressed, we know that one of these will be true. How can we tell if the mouse is dragging? Well, if the mouse position moves and one of those buttons is pressed, then we know it's dragging. So we can say is dragging equals, and we'll say get.mouse button pressed 0 or get.mouse button pressed 1 or get.mouse button pressed 2. That's kind of long, but it's really simple. So basically what we're saying is if any of the mouse buttons are pressed and the mouse has just moved, then clearly the user is dragging something now. So we just do this or statement, which basically says if this is true or this is true or this is true, then this will all be true. So that's how we check for dragging, and that should be it for our mouse listener. How do we register these callbacks now? Well, in Java 8 and above, I believe, it might be 11 and above, we have these things called Lambda Expressions, which is basically what GLFW is going to be expecting. So inside of our init loop, this is where we would set up our callbacks, and we would do this right after we create the window, because we need a window in order to set a callback for that window. So we would do it right down here, and we can just say GLFW set cursor pose callback, and we'll say GLFW window, which is the window we want to set this callback for, and the function we want is mouse listener, do a colon, and then you notice we get all of our functions, and we want mouse pose callback. So this colon is something you may have never seen before. It's a Java syntax that's basically shorthand for lambda function. Lambda functions are just stuff like x goes to some function x, and we want to return, it's something like this, x plus 2 or something like that. And basically it just plugs in x everywhere. I think it might just be something like this. But basically you have these things called lambdas in Java where it just sort of forwards things to a function. We're saying forward your position callback to this function. And that's what we want to do. We want it to call our function whenever there's a cursor callback. Next, we'll say GLFW set mouse button callback, GLFW window, mouse listener, and then we'll say mouse button callback, GLFW set, and we want our scroll callback. We'll say GLFW window and mouse listener, and we'll say scroll callback, mouse scroll callback. And that should set up all of our mouse listener callbacks. And how do you know to call those functions? Remember, they showed us them right here. So these are where you would get where to call those functions, and then these are where you would get the function definitions at the GLFW org docs so that you know exactly what to call. Next, let's do our key listener. So we'll make a new class. This is going to be called KeyListener. And this one's actually going to be a lot easier because key listeners are just a lot less to deal with, really. There's not a lot of events that could happen for a key listener. So we'll say private static key listener instance. We're making this a singleton, just like the last one. And we'll say private Boolean key pressed equals new Boolean 350. I'm not quite sure why I chose that number. I'm looking at my old code. I think it may be because I Googled what the amount of key bindings that GLFW has, and it might be 350. Okay, and then we'll make a private constructor just to make sure that no other classes call this. It's going to be empty because we don't really need to do anything. When you create an array in Java, it initializes that array to be empty, full of zeros, which is what we want. So, or false, which is what we want. Then we'll make a key callback. And this takes in a window and a key, and I believe it takes in an action. Nope, it takes in a scan code, action, and modifier. So we have a scan code, we have an action, and we have mods. So once again, the modifiers are just any keys that are pressed in addition to this key. The action is like GLFW key press, key release. Scan code, I'm not completely sure on. I'll have to check the docs on that. And then key is just which key was pressed. We'll say if action equals GLFW press, then we will say get.key pressed. And we'll say key equals true. Let's create that get function real quick too, just so that we have that. So we'll say public static key listener get, and then we will say that if the key listener dot instance equals null, then the key listener dot instance equals a new key listener. That will initialize our key listener first, and then we'll just say return key listener dot instance, and that should take care of the get function for us. Then we'll say else if action equals GLFW release, then we want to set that to false, so we'll just say get.keyPressed key equals false. Whoops. And then we can import that, alt enter, and I'm not going to check and see if these are inbounds because I believe I captured all the possible cases with that 350. If I'm wrong on that, comment below and I will add an addendum to this video just to let everyone know. Then we'll make our getter function. We'll say static Boolean is key pressed, and we'll pass in the key code we want to check for, and then we'll just return get.key pressed and key code. And if you want to be really safe, like we were in the last one, you could wrap this in an if statement. We could just say if key code is less than get.keyPress.length, we'll return this. Otherwise, we'll return false. Just in case if the user passes in some junk, we want to make sure that they don't get it. You could have it return the error though. I don't know. I think I might want this to return an error because if the user passes in some junk, they may not know that they're passing in some junk. That might be an error with the program, and I think I'd rather that throw a null pointer exception or an array out of bounds exception so that we know, hey, something is going seriously wrong because we're getting a key press that should never exist. But that should be it. Now let's register this with our window. So we'll go to here and then we'll say GLFW set key callback, give it the window, and we'll say key listener, and we'll say key callback, which sets up all our listeners. Now all of our listeners are set, and we should be able to query for key events. So let's go to our loop. We have our pull events right here. Then we have our clear color. Let's just test this out real quick. Say system.out.println. Well, actually, we'll just say if key listener is key pressed, and then we'll say GLFW key space. Then we'll say system.out.println, and we'll say space key is pressed. So if we run this real quick, and I'm going to make the window smaller, and if you hit space, you notice it says space key is pressed. So that's good. That's telling us exactly what we need to know. I would go through and test all the other functions we did just to make sure they're all working properly if I were you. I believe they're all correct. If they're not, we'll have bugs later on and we'll find out about that. But that looks good to me. Now let's do a cool thing real quick. Instead of doing this, let's go up here real quick. We'll just say private float RGBA, and we'll go down to our creation function r equals 0, b equals 0, g equals 0, and a equals 0. And let's create a cool little fade to black thingy when you press space. So right now we will pass in r, g, this is going to be b, and this one's going to be a. And let's actually set those to 1 because that's probably better. 1, 1, and 1. And then what we can do is we can say if the space key is pressed, we'll fade to black equals true. And then let's just go up here real quick one more time. And we'll say private. This is not going to stay 2, so if you don't want to copy this, don't copy it. Fade to black equals false. And then we can say, since this is now true, we'll just say if fade to black, then r equals math.max, r minus dt. Oh, do we have dt? We don't have dt. We'll add that in the next tutorial too. Say r minus equals 0.01 f or 0. G equals math.max, g minus 0.01 f or 0. And then b equals math.max, B minus 0.01F or 0. So now we should get it to fade to black when we press the space key. So let's go into here, space key, and it fades to black. So cool, we have a cool little transition thing, and you can change this to any color you want. What's happening here is we're basically just saying decrease R, G, and B in equal distance every frame until it fades to black. So just a fun little thing that we could do to illustrate how this all works, and it happens when we press the space key. So we have some user interaction. And last other thing I want to mention is you can check for controller keys. If we go back to GLFW's documentation, we have this joystick input. So you can set up key listeners for joysticks, which is for controllers, joysticks, everything, joystick button state, and all these different things. They have it built in, and they will detect all this stuff for you. You just have to set up the appropriate callbacks, and it will work as you would expect. And then they also have the gamepad input. So if you want to make your game compatible with a gamepad, I highly encourage you to try this out. Check it out and see if you can get this stuff working, and then hook up your controller to your PC and see if you can get it to work. But that is it for this tutorial. I hope you guys learned something, and I hope this helped you out with how key listeners and mouse listeners work. In the next tutorial, what we're going to do is we're probably going to set up the delta time variable and get all that working. And then we are also going to start setting up our scene management so that we can actually do our tests and stuff in scenes instead of just sort of throwing code into this. But I hope you guys like this. If you did, please hit like and subscribe, and I will see you next time. Thanks. See ya.